Hi, my name is Mary Beth Lachak. I'm the Director of Strategic Communications at the Canada-France-Hawaii Telescope. Today is July 20th, which is the 51st anniversary of the moon landing, the first time people stepped foot on another world. That occurred on July 20th, 1969 as part of the Apollo 11 mission. Now, before we can talk about the moon landing, we need to talk a little bit about the Earth. That's where our story starts. So the Earth has gravity. Now this is great for us. If I lift the Earth up here and drop it, we see that the Earth's gravity pulls things down towards its surface. Fantastic, that's what keeps us from floating off the Earth. But if we want to go to another world, like the moon, we need to travel fast enough to escape that Earth's gravity. Now in astronomy, we call that the escape velocity. The escape velocity of the Earth is about 25,000 miles per hour. Now to escape the Earth's velocity, we need a rocket. Now our rocket has something called thrust, and when it has the fuel, it can travel fast enough to escape the Earth's velocity and travel to the moon, where it's able to use the moon's gravity to either orbit or to get close enough to land. Now, when we want to talk about thrust and how we can create a rocket that shoots out from the Earth and travels fast enough, we can't do that in our backyard. That requires way too much energy than we have at home. However, we can make a miniature rocket to learn a little bit more about how rockets work. To create our rocket, we need a couple of ingredients. We need a film canister. When we're looking at these kinds of canisters, it should be a container that the lid fits inside the container. That's really important for this experiment. The next thing we need is Alka-Seltzer tablets. So it doesn't have to be the name brand Alka-Seltzer. It can be any kind of fizzing tablet as long as it has the ingredients of sodium bicarbonate, which is basically baking soda, and some citric acid. What we're gonna do is break up our tablet of Alka-Seltzer. You don't need the whole thing. Somewhere around a third to half the tablet works well. So we're gonna be really careful, and you don't wanna stand too close to your rocket after this next step. You're probably gonna wanna do this outside and with an adult. So we have to act pretty fast. What we're gonna do is pour water, not a lot of water, but a little bit of water in our container. We're gonna put the lid on, and then we are gonna step away. So the reason that our rocket launches is because we've created a chemical reaction. When we add water to the Alka-Seltzer, carbon dioxide is created. As the tablet dissolves, we get that carbon dioxide gas, and that gas builds up inside of our rocket. That creates an incredible amount of pressure. The carbon dioxide gas is just dying to get out of that container, and it has enough energy that creates a force to pop that container very high up in the air. The first time that we did this today, the container almost got stuck on the roof here at CFHT. That's how high it flew. Now, if you want to try this experiment at home and don't have Alka-Seltzer, you could try the same thing, except you would use plain baking soda and either lemon juice or vinegar. Put that in your film canister, and you can find these either online or from a friend. Maybe Auntie has one. Pill containers also work. Anything where the lid snaps inside the container. So you can really try and experiment and see what kind of fuels power your rocket. All of this happens because of a chemical reaction. Now, when that rocket goes fast enough, it's able to go at that escape velocity, fly off of the surface of the Earth, and take us to other worlds, like the moon or Mars or any of the planets in our solar system. So anytime an object leaves the Earth to explore space, unless it stays in an orbit around the Earth, it's traveling at the Earth's faster than the escape velocity of the Earth.